as night slowly settles across the world, and the final sounds of a busy day begin to fade into silence. Perhaps this is the perfect moment to lift our eyes toward the stars. For thousands of years, people have done exactly that. Long before telescopes, long before rockets, and long before anyone understood the true scale of the universe, our ancestors looked into the night sky with the same sense of wonder we still carry today. Those distant stars guided travelers across deserts and oceans. They inspired myths, religions, and civilizations. But perhaps more than anything else, they awakened one timeless question: who are we within this vast universe? Tonight, we begin a different kind of journey. No spacecraft is required, no astronaut's suit, only a quiet mind, a comfortable place to rest, and the gentle willingness to let your imagination drift. Together, we will travel backward through time to the very beginning of the universe. We will witness the birth of the first stars. We will wander among enormous galaxies that stretch across unimaginable distances. We will venture close to mysterious black holes whose gravity bends space and time. We will visit distant worlds orbiting stars far beyond our own solar system. And along the way, we will quietly explore some of the greatest mysteries that science is still trying to understand today. Yet this is not simply a story about astronomy. It is also a story about ourselves. Carl Gustav Jung devoted much of his life to exploring another kind of universe, the hidden universe within the human mind. He believed that beneath our ordinary awareness lies something far deeper. A vast inner world filled with symbols, dreams, forgotten memories, and unseen patterns that quietly shape our lives. In a remarkable way, the cosmos seems to reflect that same mystery. The farther we look into space, the deeper we find ourselves asking questions about existence, about time, about consciousness, and about our own place within this immense and beautiful creation. Throughout this documentary, you will discover 100 fascinating facts about the universe, presented with a calm, gentle rhythm designed to help you relax and slowly drift towards sleep. Together, we will learn why looking into space is also a journey into the past, why every atom inside your body was forged within stars that died billions of years ago, what scientists believe may be hidden within dark matter and dark energy, and how the most powerful telescopes ever built continue to expand the boundaries of human understanding. But there is no need to remember every detail. There will be no test, no rush, no destination you must reach. Simply allow each story to arrive like another quiet wave upon the shore, carrying you gently from one wonder to the next. If tonight you are searching for a peaceful place where your thoughts can finally slow down, a place where curiosity and rest can exist together, then I hope this journey becomes a quiet companion before sleep. Welcome to Stories for Sleep, where science, nature, and the hidden depths of the human soul come together in calm, thoughtful stories designed to help you unwind, reflect, and end the day in peace. If you enjoy exploring the universe, if gentle scientific storytelling helps you relax, or if you're simply looking for a quiet place to listen before falling asleep, consider subscribing and turning on notifications. Your support allows us to continue creating these peaceful journeys, exploring not only the mysteries of the cosmos, but also the endless landscapes of the human mind. And now, take one slow, comfortable breath. Let your shoulders relax. Allow the worries of today to quietly drift away. Above us stretches a sky filled with countless stars. Ahead of us lies a journey spanning more than 13 billion years of cosmic history. And perhaps, while exploring the most distant reaches of the universe, we may also discover one quiet corner of ourselves that has been waiting patiently to be found. So settle in, get comfortable, and let the stars guide us into the night. Part 1. The beginning of the journey and the birth of the universe. Perhaps, long ago, When our earliest ancestors first looked up at a sky filled with stars, they felt something very much like we do today, a feeling of being both wonderfully small and deeply amazed. Thousands of shimmering stars stretched endlessly overhead, as though telling a story older than every civilization, older than every mountain, and older than every ocean on Earth. Tonight, we are going to listen to that story together. This is more than a journey through astronomy. It is a slow voyage backward through time, returning to the very first moment when everything we know had yet to exist. There was no Earth, no Sunday, no galaxies, no planets, no starlight, and no living creature to gaze up at the heavens. There was only a newborn universe, so unimaginably small that it lies almost beyond the limits of human imagination. For many years, the phrase Big Bang led people to picture an enormous explosion occurring somewhere in empty space. Modern science, however, tells us that this picture is not entirely accurate. The Big Bang was not a bomb exploding into the universe, because there was no space, at least not in the sense we understand it today. What actually happened was even more extraordinary. Space itself began to expand. Matter was not flying into emptiness. The emptiness itself was growing. Imagine tiny dots drawn on the surface of an uninflated balloon. As the balloon slowly inflates, the dots do not move across the surface on their own. Yet the distance between them steadily increases. The galaxies in our universe behave in much the same way. They are not racing through a motionless void. Rather, the very fabric of space-time is expanding, carrying every galaxy along with it. About 13.8 billion years ago, all the matter and energy in the universe existed in an incredibly hot, unimaginably dense, and astonishingly tiny state. Temperatures were so extreme that even the fundamental particles we know today could not yet combine into stable structures. There were no atoms, no molecules, only a vast ocean of energy where particles continually appeared and disappeared over intervals so brief that they are almost impossible to imagine. As the universe continued to expand, it also began to cool. That cooling marked the opening chapter of creation. Quarks combined to form protons and neutrons. Then, within the first few minutes, the nuclei of the lightest elements, primarily hydrogen and helium, began to emerge. Hundreds of thousands of years later, the universe cooled enough for electrons to join those nuclei, creating the very first atoms. Light, which had previously been trapped within the dense, opaque universe, was finally able to travel freely through space. That ancient light still exists today as the cosmic microwave background, a faint echo from the universe's first dawn. Time itself began to acquire meaning. Distance became something that could be measured. Space continued to unfold. Regions that contained just a little more matter than their surroundings slowly collapsed under the force of gravity, becoming the seeds of galaxies, star clusters, and the immense cosmic structures that modern telescopes observe today. It is remarkable to realize that every breathtaking sight in today's night sky began with unimaginably tiny fluctuations in the newborn universe. Yet the story becomes even more personal when we recognize that this history does not belong only to the stars. It is also our own history. During the first minutes after the Big Bang, the universe produced only the simplest elements, hydrogen and helium, along with tiny amounts of lithium, the familiar elements that make life possible. Carbon, oxygen, nitrogen, silicon, calcium, and iron did not yet exist. They had to wait for the first stars to be born. Deep within the cores of those stars, immense pressure and extraordinary temperatures fused hydrogen into helium, and then forged increasingly heavier elements through nuclear fusion. When the largest stars reached the end of their lives, they exploded as spectacular supernovae, scattering those newly created elements across the cosmos. From those vast clouds of enriched gas and dust, new generations of stars were born, along with new planets, and eventually our own Earth. That means every carbon atom within your body, every oxygen atom you breathe, the calcium in your bones, the iron flowing through your blood, and even the atoms that quietly make your heart beat were all forged inside stars long before our solar system ever existed. That is not poetic metaphor. It is one of the fundamental truths of astrophysics. In a profoundly beautiful sense, we are truly made of stardust. Yet perhaps what makes this truth so moving is not the atoms themselves. It is the journey they have taken. The atoms within your body have traveled across space for billions of years. They were once part of ancient stars. They drifted through enormous nebulae. They witnessed the birth and disappearance of countless galaxies before finally coming together to become life on a small planet orbiting an ordinary star near the edge of the Milky Way. Carl Gustav Jung once wrote in Memories, "Dreams, reflections. Who looks outside, dreams. Who looks inside, awakes." Perhaps those words have never felt more meaningful than when we stand beneath a sky full of stars. Every time we lift our eyes toward the universe, we imagine that we are looking outward into unimaginable distances. Yet perhaps the same journey is quietly leading us inward, toward ourselves. For the greatest questions of astronomy and the deepest questions of the human soul begin in exactly the same place: wonder. Perhaps that is the universe's greatest gift to humanity. It has not only given us life, it has also given us the ability to ask what life truly means. And as night continues to spread across the sky, allow your thoughts to drift gently among the distant stars. Imagine that every point of light above you is another chapter in the greatest story ever told, while we have only just begun turning its first pages. Countless wonders still lie ahead, waiting to be discovered, and our journey has only just begun. Part 2. To look at the universe is to look back in time. Perhaps one of the greatest wonders of the universe is not its unimaginable size, nor the almost endless number of stars and galaxies scattered across it. Its greatest wonder lies in a quiet truth that we often forget whenever we lift our eyes to the night sky. The truth is, we have never seen the universe as it exists right now. Every star, every planet, every faint ribbon of light stretching across the heavens is telling us a story that has already happened. That may sound more like poetry than science, yet modern physics tells us it is simply the nature of light. Although light travels at the fastest speed, we know about 300,000 kilometers per second through the vacuum of space, it still takes time to journey from its source to the observer. That span of time forms a bridge between the past and the present. Every time we gaze into the sky, we are looking across that bridge. Let us begin with Earth's closest celestial companion. Light reflected from the moon takes about 1.3 seconds to reach our eyes. In other words, the moon you are seeing is actually the moon as it was a little more than 1 second ago. The difference is so small that we never notice it, but when we turn toward the sun, the delay becomes much greater. Sunlight requires approximately 8 minutes and 20 seconds to reach Earth. If something extraordinary were to happen to the sun at this very moment, we would not know about it for more than 8 minutes, because the light carrying that information would still be making its way toward us. Beyond the sun lie the stars. The brilliant star Sirius, shining brightly in the winter sky, is about 8 light-years away from Earth. That means the light reaching your eyes tonight actually left Sirius 8 years ago. When we observe galaxies millions or even billions of light-years away, we are literally looking into the history of the universe. Some galaxies are so distant that the light we receive today began its journey before human beings ever existed on Earth. Others are so remote that their light departed when complex life had not yet appeared on our planet. And there are galaxies whose light began traveling toward us when the Milky Way itself was still young. That is why astronomy is often compared to reading an immense cosmic diary. Every distance is another page. Every beam of light is another memory. And every more powerful telescope, allows us to turn yet another page farther back into a story that stretches across billions of years. This is what makes astronomy such an extraordinary science. Geologists dig deep beneath the Earth to uncover its past. Archaeologists excavate the remains of ancient civilizations. Astronomers simply point their telescopes toward the sky. The past comes to them in the form of light. Few ideas are both so simple and so astonishing. Yet the universe surprises us once again. Time itself, which seems to flow steadily in our everyday lives, does not pass at exactly the same rate everywhere. Here on Earth, a minute always seems to last a minute. An hour always feels like an hour. The watches on our wrists appear to move in perfect agreement. But according to Albert Einstein's general theory of relativity, time is not an absolute, universal flow. Space-time is more like an enormous fabric. Massive objects, planets, stars, and black holes bend that fabric. That curvature is what we experience as gravity. And remarkably, when space is curved, time changes as well. Near objects with extremely strong gravity, time passes more slowly than it does in regions where gravity is weaker. This phenomenon is known as gravitational time dilation. It is not merely a mathematical curiosity. The GPS satellites orbiting Earth must continually adjust their onboard clocks to account for relativistic effects. Without those corrections, the navigation systems we rely upon every day would quickly accumulate significant errors. One of the places where time changes most dramatically is near a black hole. A black hole does not merely bend the path of light. It also slows the passage of time to an almost unimaginable degree. If an astronaut could somehow remain safely near the event horizon of a supermassive black hole and later return to Earth, they might experience only a few hours, while many years or even much longer could have passed here, depending on their distance from the black hole and the specific conditions involved. It sounds like science fiction, yet it is a perfectly natural consequence of the equations that describe space-time. Suddenly, we realize that time is not a single clock hanging above the universe. Every region of the cosmos follows its own rhythm. There are places where time nearly slows to a standstill. There are places where light requires billions of years to complete its journey. And there are ancient memories of the universe that are still quietly traveling through space, waiting for the day when a telescope finally receives them. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "Who looks outside, dreams. Who looks inside, awakes." Perhaps those words carry an especially beautiful meaning beneath a sky filled with stars. Whenever we look out into the universe, it feels as though we are traveling farther and farther away from ourselves. Yet perhaps that same journey is quietly bringing us home. Just as light requires immense stretches of time to reach our eyes, many experiences in our own lives also need time before we truly understand their meaning. Some joys reveal their true value only after they have passed. Some sorrows become wisdom only after many years. And some memories, though they seem to have faded into silence, continue to shine quietly within us, much like distant stars, whose ancient light is only now arriving on Earth. Jung repeatedly reminded us that we do not live solely in the present moment. We are shaped by memory, by symbols, and by the deeper layers of the unconscious that accumulate throughout our lives. In that sense, the human soul is not unlike the night sky. What we see on the surface is only enough light to illuminate a small part of its vastness. Beneath it remain countless regions, still waiting to be explored, and perhaps that is the universe's most beautiful gift. Whenever we look up into the night sky, we are not simply looking into endless space. We are looking at time. We are looking at memory. We are looking at the history of light itself. And perhaps, within that profound silence, we are also learning to listen to the quiet story of our own souls. As night continues to gently embrace the heavens, and the stars keep shining with light from the distant past, allow your thoughts to slow to the rhythm of the universe. Our journey has only just begun to turn its earliest pages, and countless wonders still wait patiently to be told. Part 3. The things we cannot see. In the previous chapter, we discovered that every ray of light reaching us from the night sky carries a memory from the past. Tonight, our journey takes us somewhere even more extraordinary, to the things that light itself cannot reveal. When we look up at the sky on a clear night, it is easy to feel as though we are seeing the entire universe. Thousands of sparkling stars, the soft, luminous band of the Milky Way, the familiar planets of our own solar system. All of them come together to create a panorama so immense that it reminds us how small we truly are. Yet modern science quietly tells us something astonishing. Everything we can see is only a tiny fraction of the universe. Like moonlight dancing across the surface of the sea while the vast majority of the ocean remains hidden beneath the waves, the universe is much the same. Light allows us to observe only about 5% of all the matter and energy that exist. The remaining 95% remains almost entirely invisible. That means nearly all of the universe is made of things we cannot observe directly. It sounds almost like mythology, yet it is the conclusion reached after decades of research in astronomy and modern physics. The first invisible component is known as dark matter. Its name sometimes leads people to imagine a mysterious black substance that somehow emits darkness. But that is not what it means. It is called dark simply because it neither emits light, reflects light, nor interacts with light in the same way as ordinary matter. We cannot see it, but we can see its fingerprints. Galaxies rotate far faster than the visible matter within them can explain. If galaxies contained only the stars, planets, gas, and dust that our telescopes detect, many of them should have flown apart billions of years ago. Instead, they remain remarkably stable. It is rather like watching leaves sway in the wind. You cannot see the wind itself, yet you know it is there. Dark matter is much the same. We have never observed it directly, but its gravitational influence appears throughout the universe. The second invisible ingredient is even more mysterious. It is called dark energy. If dark matter helps hold galaxies together, dark energy appears to be doing almost the opposite. Observations made near the end of the 20th century revealed that the universe is not merely expanding, its expansion is accelerating. Something unseen seems to be gently pushing space itself to grow ever larger. Scientists call that phenomenon dark energy. Even today, we still do not know exactly what it is. That is not a failure of science. It is one of science's greatest strengths. Science does not begin with certainty. It begins with the honesty to say, we still don't know. Perhaps it is that humility that has allowed human knowledge to continue moving forward. When we look into the night sky, we are often overwhelmed by the countless stars shining above us. Yet even those stars represent only a tiny glimpse of reality. Current estimates suggest that the observable universe contains hundreds of billions of galaxies, and that each galaxy holds anywhere from tens of billions to hundreds of billions of stars. The total number of stars is so enormous that it is almost impossible to express in ordinary numbers. Astronomers often say that there are more stars in the observable universe than there are grains of sand on all the beaches and deserts of Earth. The comparison is not mathematically exact, but it offers a glimpse of the universe's almost unimaginable scale. Imagine every grain of sand as a star. Every star may have planets of its own, and perhaps, somewhere within that vast cosmic ocean, there are other skies, other oceans, and other beings who also look upward and wonder, just as we do. Yet even the immense distances between the stars are not truly empty. For centuries, people believed that space was nothing more than a silent vacuum. Today, we know that this apparent emptiness is filled with invisible physical fields. Electromagnetic fields carry light across the cosmos. Magnetic fields guide streams of charged particles. Cosmic rays continually race through our galaxy with astonishing energies. The cosmic microwave background still quietly echoes from the universe's earliest moments. And at the quantum level, even empty space is never completely empty. Tiny quantum fluctuations constantly appear and disappear over unimaginably brief intervals, reminding us that perfect stillness may never truly exist. The universe is quiet, but it has never been motionless. It is always vibrating with rhythms that our senses cannot directly perceive. Carl Gustav Jung once wrote in The Archetypes and the Collective Unconscious, "In addition to our immediate consciousness, which is of a thoroughly personal nature, there exists a second psychic system of a collective, universal, and impersonal nature, which is identical in all individuals." Jung was describing the collective unconscious, a profound layer of the human psyche that, in his view, extends far beyond each individual's personal experience. He was not speaking about dark matter or dark energy, and yet, viewed through the language of symbolism, it is difficult not to notice a beautiful parallel. The universe is shaped largely by things we cannot see. Our inner lives are much the same. The thoughts that rise into consciousness are like the bright stars scattered across the night sky. They are easy to recognize and easy to name, but beneath them lies an immense ocean of memories, intuitions, emotions, and unconscious patterns that quietly influence how we love, how we fear, how we choose, and how we grow. Perhaps that is why the more we learn about the universe, the more humility we gain. We become less certain that everything we see is everything that exists. For light has its limits. Telescopes have their limits. Even the human mind has its limits. But curiosity, it seems, does not. And perhaps the greatest gift the night sky offers us is not a complete collection of answers, but the quiet ability to live peacefully beside the unknown, while the stars continue to shine gently above us, and most of the universe remains hidden from view. We begin to understand that the beauty of existence does not depend on every mystery being solved. Sometimes the greatest beauty is found within the darkness that still waits to be explored, reminding us that both the cosmos above and the soul within still hold countless wonders, patiently waiting to be discovered. Part 4. The Solar System from a New Perspective. After exploring the opening chapters of our cosmic story from the moment the Big Bang gave birth to space and time, to the mysteries of dark matter and dark energy, perhaps it is time to journey a little closer to home. But do not let familiarity fool you. The solar system we first encountered in childhood textbooks is not a peaceful family of nearly identical planets quietly circling the Sunday. Instead, each world possesses its own personality, its own history, and a beauty unlike any other. Much like each human life carries its own unique story. At the center of it all is the Sunday. Every morning, when the first rays of sunlight touch the earth, we rarely stop to consider what makes that gentle light possible. Quietly, every second, the sun gives away a part of itself. Deep within its core, hundreds of millions of tons of hydrogen are continually fused into helium through the process of nuclear fusion. According to Albert Einstein's famous equation, a tiny fraction of that mass is transformed into energy in the form of light and heat. As a result, the sun loses about 4 million tons of mass every second. The number sounds almost unimaginable. Yet for a star whose mass is roughly 330,000 times greater than Earth's, that loss is no more significant than a single grain of sand falling from a vast mountain. Perhaps the sun's greatest beauty does not lie in its power, but in its quiet generosity. For more than 4.5 billion years, it has silently transformed part of itself into light, sustaining every living thing on our small world. Travel a little farther outward, and we arrive at Jupiter, the largest planet in the solar system. Seen from afar, Jupiter sometimes appears almost like a star that never quite came to life. During the formation of the solar system, it gathered an enormous amount of gas and became the giant of its planetary family. Yet to ignite nuclear fusion and truly become a star, it would have needed roughly 80 times its current mass. Only a little more, at least from a human perspective. But in astronomy, that difference is an immense gulf. Jupiter did not fail to become a star. It was simply born to become itself. Farther still, Saturn appears like the jewel of the solar system, surrounded by magnificent rings that seem broad and solid when viewed through a telescope. Yet the reality is wonderfully surprising. Although Saturn's rings stretch across hundreds of thousands of kilometers, most of them are only tens to hundreds of meters thick. In many places, if scaled down proportionally, they would resemble an enormous sheet of paper floating through space. Sometimes, what astonishes us most is not size, but fragility. Continuing our journey, we arrive at Venus, Earth's closest planetary neighbor. At first glance, Venus is remarkably similar in size to our own planet. Yet if you could stand upon its surface, you would encounter one of the solar system's strangest paradoxes. A single rotation of Venus takes about 243 Earth days, yet it completes one orbit around the Sun in only 225 Earth days. In other words, a day on Venus lasts longer than its entire year. Even within a single planetary system, time refuses to keep the same rhythm everywhere. Mercury, the planet closest to the Sun, tells an entirely different story. With daytime temperatures hot enough to melt many metals, scientists once believed Mercury was completely dry, yet spacecraft have discovered deposits of water ice hidden within craters near its poles, places where sunlight has never reached. Even the hottest world can preserve ice. Even the driest landscape can still shelter water. Mars offers another quiet reminder. Today, the red planet appears as a cold desert, blanketed in iron-rich dust. Yet geological evidence reveals that billions of years ago it possessed rivers, lakes, and perhaps even vast oceans. That realization has inspired one of astronomy's greatest questions. Could a world once filled with water also have been capable of supporting life? We still do not know the answer. But questions like that continue to send robotic explorers across the Martian landscape. Farther from the Sun lies Uranus. Unlike nearly every other planet, Uranus rotates with its axis tilted by almost 98 degrees. Viewed from a distance, it appears almost to roll around the Sun instead of spinning upright. No one knows with certainty why it tilts so dramatically. Perhaps a colossal collision early in the solar system's history knocked it onto its side. Whatever the cause, that extraordinary difference created a world unlike any other. At the far edge of the solar system, Neptune continues to surprise astronomers. Although it receives less than 1/1000th of the sunlight that reaches Earth, this deep blue world is home to winds exceeding 2,000 kilometers per hour faster than the speed of sound within Neptune's own atmosphere. Amid temperatures approaching absolute zero, the winds never stop, as though even the stillness of the universe possesses its own quiet rhythm. Carl Gustav Jung once wrote in Psychological Types, "The shoe that fits one person pinches another." There is no recipe for living that suits all cases. Jung was speaking about people, the uniqueness of personality, and the individual path each person must follow. He was not writing about planets, yet when we look at the solar system, his words seem to take on a beautifully symbolic meaning. Within the same family of the Sun, no two worlds are alike. Each planet has its own rotation, its own climate, its own history, its own laws of nature. None must become a copy of another in order to have value. Perhaps the same is true for us. We often compare our lives with those of others, wondering why someone else moves faster, succeeds earlier, or follows a different rhythm. But nature has never worked that way. The universe does not ask Venus to become Earth, nor does it expect Uranus to stand upright like Jupiter. Every world possesses a beauty that arises from its own uniqueness, and as night continues to embrace the sky, Imagine the entire solar system quietly moving through the vastness of space. 8 planets, hundreds of moons, countless asteroids, and wandering comets all continue along their own paths, never rushing, never competing, never trying to become something they were never meant to be. Perhaps that is the gentlest lesson the night sky has to offer. Every life follows its own orbit, and true beauty is found not in becoming someone else, but in patiently becoming yourself. Part 5. The extraordinary worlds of the solar system. If the solar system is our home, then every planet and every moon within it is like a different room, each with a story all its own. Some are familiar and comforting. Others are so strange that, had spacecraft never sent back their photographs, it would be difficult to believe they truly exist. Tonight, as your mind grows quieter beneath a sky full of stars, let your imagination gently carry us away from Earth. We will journey to places where sunlight has faded into little more than a distant glow, where ice is as hard as rock, where oceans lie hidden beneath shells of frozen crust, tens of kilometers thick, and where volcanoes tirelessly reshape entire worlds. Our first destination is Pluto. Although Pluto is now classified as a dwarf planet, that title does nothing to diminish its wonder. When the New Horizons spacecraft flew past Pluto in 2015, humanity saw, for the very first time, a vast, heart-shaped plain covered with frozen nitrogen and magnificent mountain ranges built not from granite, as they are on Earth, but largely from water ice. At temperatures near -230 degrees Celsius, water ice becomes so hard that it behaves like solid rock on our planet. Meanwhile, frozen nitrogen and carbon monoxide remain much softer, flowing slowly across the landscape like glaciers. What we call rock on Earth is ice on Pluto. A simple change in temperature is enough to transform the rules by which an entire world exists. Leaving Pluto behind, we arrive at Titan, Saturn's largest moon, and one of the most fascinating places in the solar system. From a distance, Titan is wrapped in a thick golden-orange atmosphere that completely hides its surface. Only when the Cassini spacecraft and the Huygens lander arrived did humanity uncover an extraordinary surprise. Titan has clouds, it has rain, it has rivers, it has lakes, it even has seas, but instead of water, they are made of liquid methane and ethane. An entire weather cycle unfolds on Titan. Clouds gather, rain falls. Liquid flows into rivers and fills vast lakes before evaporating once again into the atmosphere. Nature always seems to find harmony. Each world simply composes its symphony using different ingredients. Farther along our journey lies Europa, one of Jupiter's moons. From the outside, Europa appears to be little more than a white sphere of ice crisscrossed with long fractures. Yet measurements of its magnetic field and geophysical observations strongly suggest that beneath its frozen shell lies a vast ocean of liquid water, perhaps tens to more than 100 kilometers deep. That hidden ocean may contain more water than all of Earth's oceans combined. Complete darkness, no sunlight, no sunrise. And yet this silent world is considered one of the most promising places in the solar system where extraterrestrial life might exist. Perhaps that reminds us that life does not always flourish where the light shines brightest. Sometimes the greatest wonders grow quietly where our eyes cannot see. Another of Saturn's remarkable moons is Enceladus. If Europa keeps its secrets beneath a shell of ice, Enceladus seems eager to share them with the universe. From enormous fractures near its south pole, towering plumes of water vapor and ice crystals erupt continuously into space. These geysers contain water, salts, organic compounds, and many other molecules. Because of them, scientists can study the chemistry of the hidden ocean below without ever drilling through the ice. It is as though the moon is slowly opening the pages of its own book. Sometimes the universe is surprisingly generous. If Enceladus represents quietness beneath the ice, then Io, another of Jupiter's moons, embodies relentless power. Io is the most volcanically active world in the entire solar system. Hundreds of volcanoes erupt continuously, sending towering plumes hundreds of kilometers above its surface. Rivers of molten rock and sulfur constantly reshape the landscape. The source of this extraordinary activity is Jupiter's immense gravity. Combined with the gravitational pull of neighboring moons, these relentless tidal forces continually squeeze and stretch Io's interior, generating tremendous heat. Some worlds are shaped by tranquility, others are forged through endless upheaval. Both belong equally to the universe. Continuing onward, we arrive at Ganymede. It is the largest moon in the solar system, even larger than the planet Mercury. Had Ganymede orbited the Sun directly instead of Jupiter, it might very well have been called a planet. Its size is not its only distinction. Ganymede also possesses its own intrinsic magnetic field, an exceptionally rare feature for a moon. Even the categories we invent, planet or moon, are simply ways of organizing the universe. Nature itself is never constrained by the names we give it. Far beyond, orbiting Neptune, we encounter Triton. Unlike almost every large moon in the solar system, Triton travels around its planet in the opposite direction of Neptune's rotation. For this reason, scientists believe Triton was not born alongside Neptune. Instead, it was likely once an independent object in the Kuiper belt, captured by Neptune's gravity billions of years ago. A traveler, a visitor from far away, who eventually found a new path to follow. Carl Gustav Jung once wrote in Modern Man, In Search of a Soul, "The privilege of a lifetime is to become who you truly are." Jung was describing the process of individuation, the lifelong journey of becoming one's authentic self, by integrating the different parts of the psyche. He was not writing about planets or distant moons. Yet if we view the solar system through the language of symbols, it is difficult not to feel a beautiful resonance. No two worlds are alike. Pluto tells its story through mountains of ice. Titan speaks through methane rain. Europa hides an ocean beneath eternal darkness. Enceladus sends water soaring into space. Io lives through fires that never truly rest. Ganymede quietly carries the scale of a planet within the identity of a moon. Triton remains faithful to its own backward orbit. Not one of these worlds must abandon its nature to become valuable. Perhaps the same is true for us. Each of us carries a unique inner landscape. Some memories lie frozen like Europa's hidden ocean. Some emotions flow quietly beneath the surface, unseen by others. Some passions burn with the fierce intensity of Io's volcanoes. And some parts of ourselves continue to follow a path different from everyone around us, much like Triton. Perhaps the journey of exploring the universe and the journey of understanding ourselves have never truly been separate. For the farther we travel into the vastness of space, the more clearly we realize that the universe draws its beauty not from sameness, but from diversity. And as night continues to wrap itself around the sky, allow your thoughts to drift gently across these extraordinary worlds. Perhaps, somewhere among the frozen oceans, the methane rains, and the unlikely orbits, you may quietly discover that what gives a world, just as what gives a human life, its deepest value, is not becoming like anyone else, but remaining faithful to the unique nature it was always meant to be. Part 6. Asteroids, comets, and the ancient relics of the solar system. After visiting some of the most extraordinary worlds in the solar system, it would be easy to imagine that the story of our cosmic neighborhood is written only by giant planets, frozen moons, and brilliant stars. Yet, much like human history is preserved not only in grand palaces or magnificent cities, the history of the solar system is often safeguarded by the smallest objects, ones we might easily overlook. Tonight, let your thoughts slow a little more. We are leaving the familiar planets behind to visit solitary rocks, wandering bodies of ice, and quiet travelers that have faithfully preserved more than 4 billion years of history. These are the asteroids. These are the comets. And together, they are among the oldest surviving relics from the dawn of the solar system. Between the orbits of Mars and Jupiter stretches a vast region known as the asteroid belt. In popular imagination, it is often portrayed as it appears in science fiction films, a dangerous maze, where countless rocks collide endlessly with one another. The reality is far more peaceful. The asteroids are separated by enormous distances. A spacecraft passing through the asteroid belt has only an extremely small chance of colliding with another object. Space is so unimaginably vast that even millions of rocky bodies resemble little more than scattered pebbles across an endless plain. Yet these humble rocks are among the oldest witnesses to the solar system's history. Most have never completely melted or evolved into full-fledged planets. Instead, they have preserved much of the original material that existed about 4.5 billion years ago, when the Sun and the planets first began forming from an immense cloud of gas and dust. They are like the leftover bricks from the construction of a great house. By studying them, we begin to understand how that house was first built. Among these ancient objects is one especially remarkable world called Ceres. Discovered in 1801, Ceres was originally considered a planet. Later, as more asteroids were found, it became known as the largest asteroid. Then, in 2006, alongside Pluto, Ceres was officially reclassified as a dwarf planet. Its name changed. Its nature did not. Ceres remains a fascinating world, nearly 1,000 kilometers across, large enough for its own gravity to pull it into an almost spherical shape. Observations made by NASA's Dawn spacecraft revealed abundant water ice beneath its surface, along with mysterious bright regions that were eventually identified as deposits composed largely of reflective mineral salts. A small world, yet one carrying an extraordinarily rich geological history. Perhaps, in the universe, value has never been determined by size. Leaving the asteroid belt behind, we continue toward the most famous wandering visitors of the night sky, the comets. If planets are like long-time residents living stable lives within the solar system, comets are its travelers. For most of their existence, they move silently through the distant reaches where sunlight has faded to little more than a faint glow. They are composed of water ice, frozen carbon dioxide, methane, ammonia, rocky dust, and many ancient organic compounds. Because they spend so much of their lives far from the Sun, many comets have changed very little since the solar system first formed. For this reason, astronomers often describe them as time capsules. Within every comet may lie preserved fragments of the original cloud of gas and dust that gave birth to the Sun, the Earth, and ultimately, ourselves. Whenever a spacecraft approaches a comet, it is much like an archaeologist opening an untouched chest that has remained sealed for billions of years. Not in search of gold, but in search of our own beginnings. One scientific hypothesis suggests that during Earth's earliest history, countless comets and asteroids collided with our young planet, delivering water and complex organic compounds. Although this hypothesis is still being investigated and is not considered the only explanation for the origin of Earth's water, it illustrates how these seemingly insignificant objects may have played an important role in creating the conditions necessary for life to emerge. Sometimes, the smallest characters quietly help shape the greatest chapters of history. Among all comets, perhaps the most famous is Halley's Comet. Unlike most comets, which appear only once before disappearing from human view, Halley's Comet faithfully returns to the inner solar system every 75 to 76 years. Its appearances have been recorded by civilizations for thousands of years. In the 18th century, The astronomer Edmund Halley realized that what had seemed to be different comets were actually repeated visits from the very same object. He predicted that it would return in 1758. Although he did not live to witness its arrival, his prediction proved correct. From that moment onward, the comet proudly carried his name, a lasting tribute to the power of scientific reasoning. Yet Halley's comet leaves behind more than its magnificent glowing tail. Each time it passes through the solar system, it scatters countless tiny particles of dust along its orbit. When Earth crosses that stream of debris at certain times of the year, those particles plunge into our atmosphere at tremendous speeds, heating through friction until they blaze across the sky as the streaks of light we call meteor showers. The shooting stars beneath which we so often make wishes are not stars at all. They are tiny grains of dust, smaller than pebbles, yet upon touching Earth's atmosphere, they create one of nature's most breathtaking spectacles. Perhaps beauty has never depended on size. Perhaps it depends on the moment. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "The least of things with a meaning is worth more in life than the greatest of things without it." Jung was speaking about meaning within the human psyche. He was not writing about comets or asteroids. And yet, when we look at these small celestial bodies quietly preserving the history of the solar system, his words seem to take on another beautiful dimension. An asteroid is only a rock. A comet is only ice and dust. A grain of cometary debris is scarcely larger than a grain of sand. Yet together, they tell a story spanning more than 4 billion years. Perhaps human memory works much the same way. We tend to remember life's great milestones. Yet what truly shapes us is often something much smaller. A gentle glance, a kind word, a peaceful afternoon, or a quiet night spent beneath a sky full of stars. Those seemingly insignificant moments accumulate silently through the years, much like countless grains of cometary dust drifting through space. Then, one day, when memory enters the atmosphere of the soul, it suddenly glows, leaving behind a gentle trail of light bright enough to illuminate an entire chapter of our lives. And as night continues to quietly embrace the heavens, imagine that somewhere far beyond our sight, the comets are still continuing their journeys across billions of years. They are never in a hurry. They are never truly lost. They simply carry the earliest memories of the solar system patiently through the vastness of space. Perhaps, like the human soul itself, what matters most is not how quickly we travel, but how faithfully we preserve the things that have made us who we are. Part 7. Humanity reaches for space. After traveling together through billions of years of cosmic history from the first instant when space and time came into existence, across distant galaxies, frozen worlds, and comets carrying the memories of the solar system, tonight we arrive at a different kind of story. No longer the story of the stars, but the story of ourselves. Within a universe so vast that it seems almost infinite, there exists a small species born on an ordinary planet, orbiting an ordinary star, near the outer edge of the Milky Way. Its body is remarkably fragile. It cannot breathe in the vacuum of space. It cannot survive without water, air, and warmth. And yet this same species spent thousands of years gazing upward, until, at last, it found a way to leave its cradle. Perhaps humanity's greatest miracle is not strength, but curiosity. It was curiosity that carried us to the International Space Station, or ISS, a remarkable scientific laboratory quietly orbiting Earth at an altitude of about 400 kilometers. Every 90 minutes, the station completes nearly one orbit around our planet, allowing its astronauts to witness about 16 sunrises and 16 sunsets in a single Earth day. Imagine waking just as the sun rises above Earth's deep blue horizon. Barely more than an hour later, darkness gently returns. Then, before long, another sunrise appears. Time continues to flow, but the rhythm of day and night has completely changed. Life in microgravity is unlike anything we experience on Earth. When gravity no longer acts upon the body in the familiar way, the human body begins adapting in extraordinary ways. Blood and other bodily fluids shift toward the head, making astronauts' faces appear fuller during their first days in orbit. The spine, no longer compressed by gravity, can lengthen by several centimeters, temporarily increasing a person's height. But muscles and bones no longer need to support body weight as they do on Earth. So they gradually weaken unless exercised every day. That is why astronauts spend several hours each day working out in space, not to become stronger, but to remind their bodies that they were born on a world with gravity. Even stepping outside the station to repair a solar panel or install new equipment is an extraordinary challenge. Every astronaut must wear a specially designed spacesuit. From the outside, it appears to be little more than a bulky protective outfit. In reality, it is an entire life support system. It supplies oxygen for breathing, maintains the proper air pressure, regulates temperature, removes carbon dioxide, and shields its wearer from radiation, as well as tiny particles racing through space at extraordinary speeds. Perhaps calling it a suit is not quite enough. It is more like carrying a miniature Earth wherever you go. But before humanity could live and work in space, we first had to learn how to leave Earth itself. That became possible through rockets. The principle behind a rocket is beautifully simple. As fuel burns, extremely hot gases are expelled backward at tremendous speed. According to Newton's third law of motion, the equal and opposite reaction pushes the rocket forward. There is nothing in the vacuum of space for a rocket to push against. It does not need an atmosphere to fly. It needs only its own fuel, and the ability to generate thrust from within itself. Sometimes we move forward not because something pulls us ahead, but because we discover the courage to create our own momentum. Perhaps no moment symbolizes that human longing more clearly than the first footsteps upon the moon. On the 20th of July, 1969, Neil Armstrong stepped onto the lunar surface, leaving footprints in a layer of fine dust that had accumulated over billions of years through countless meteorite impacts. Because the moon has almost no atmosphere and no wind, those footprints may remain there for an extraordinarily long time, until future impacts eventually reshape the landscape, a moment lasting only a few seconds, preserved across spans of time far longer than the history of human civilization. The moon's surface dust, known as regolith, is fascinating in its own right. Unlike the sand on Earth, which has been rounded by water and wind over millions of years, lunar dust consists of sharp, jagged particles. It clings stubbornly to astronauts' suits, wears down equipment, and proved to be one of the greatest challenges faced during the Apollo missions. Even a thin layer of dust can tell the story of billions of years. Then comes one of the rarest sights a human being can witness. Looking back toward home, from space, astronauts see a blue sphere suspended against the blackness. Surrounding it is an atmosphere so astonishingly thin that, if Earth were reduced to the size of an apple, its atmosphere would be thinner than the apple's skin. And yet that delicate layer of air protects every ocean, every forest, every city, every living thing we have ever known. From space, there are no borders, no nations, none of the lines humanity has drawn across its maps. Only one small planet, quietly drifting through a sea of stars. Carl Gustav Jung once wrote in Symbols of Transformation, "Man's task is to become conscious of the contents that press upward from the unconscious." Jung was speaking about humanity's inward journey, about becoming aware of the hidden depths of the psyche in order to become more whole. He was not writing about journeys into space, yet viewed through the language of symbolism, it is difficult not to sense a profound connection. Every spacecraft leaving Earth begins with an immense burst of energy. Every journey toward maturity begins much the same way. We must leave behind what is familiar. We must step into the unknown. We must face loneliness, fear, and the limits of our own nature. Only then can we look back upon our lives with a broader perspective. Perhaps that is exactly what so many astronauts describe after returning home. The greatest transformation is not simply what they saw in space, it is how they learned to see Earth. From hundreds of kilometers above, our world appears impossibly small, breathtakingly fragile, and infinitely precious. And perhaps that is the gentlest gift the universe has ever offered humanity. Not so that we might conquer it, but so that, in reaching for the stars, we may learn to understand ourselves more deeply and cherish the small blue world that has nurtured every one of us since the dawn of life. As night continues to stretch quietly overhead, and Earth keeps turning through the endless sea of stars, allow your mind to rest in that peaceful awareness. For sometimes the greatest journey a human being can ever undertake is not traveling to another planet, but returning home with greater humility, deeper gratitude, and a heart that has finally awakened. Part 8. Earth in Space. After journeying through the planets, the extraordinary moons, and the vast depths of the solar system, perhaps it is time to pause for a moment and turn our attention back to home. It is a curious truth that the farther humanity has traveled from Earth, the more we have realized that our home is not something to be taken for granted. Among billions of celestial bodies drifting quietly through the universe, our blue planet appears like a fragile oasis, wrapped in invisible layers of protection that most of us rarely notice. Tonight, imagine yourself floating in space a few hundred kilometers above Earth's surface. Below you lies a world of deep blue oceans, soft white clouds, and the gentle curve of the horizon. From this distance, our planet no longer resembles a collection of crowded cities or political borders drawn by human hands. It is simply one small world, quietly turning within an endless sea of stars. And from here, you would witness one of the most beautiful phenomena nature has ever created, the aurora. For centuries, the shimmering curtains of green, violet, pink, and crimson light dancing across the polar skies have filled people with wonder. Many ancient cultures believed they were bridges between humanity and the divine, the spirits of fallen warriors, or mysterious omens. Modern science tells a story no less enchanting. The sun continuously releases streams of charged particles into space, known as the solar wind. As these particles approach Earth, most are deflected by our planet's magnetic field and guided toward the polar regions. There, they collide with oxygen and nitrogen atoms high in the atmosphere, causing those atoms to glow with brilliant colors. What we call the aurora is, in truth, a symphony between the sun and the Earth, a conversation written in light, taking place hundreds of kilometers above our heads. Hidden behind that beauty is an extraordinary system of protection. Surrounding Earth are two vast regions filled with high-energy charged particles known as the Van Allen radiation belts. Discovered in 1958 by physicist James Van Allen, these invisible belts form part of the complex interaction between Earth's magnetic field and the energetic particles arriving from space. For satellites and spacecraft, these regions demand careful planning. Electronic systems must be engineered to withstand intense radiation, and orbital paths are often selected to minimize prolonged exposure to the areas of highest radiation. Perhaps even more remarkable is the realization that the space surrounding our planet, what appears empty to our eyes, is constantly alive with invisible activity. Space has never truly been silent, nor has it ever been completely empty. Many people imagine that once a satellite reaches orbit, it will circle Earth forever, but that is not entirely true. Satellites in low Earth orbit still travel through an extremely thin outer layer of Earth's atmosphere that extends hundreds of kilometers above the surface. Although this atmosphere is extraordinarily tenuous, it still produces a tiny amount of drag. Over months and years, that nearly imperceptible resistance gradually steals orbital energy, causing satellites to descend ever so slowly. Unless they periodically raise their orbits using onboard propulsion, or were designed only for a limited mission, many eventually fall into denser layers of the atmosphere, where friction heats them until they burn brightly across the sky. A quiet ending. Like an artificial shooting star, it reminds us that even in places that seem perfectly unchanging, every movement is shaped by forces that are small, yet persistent. Perhaps no invisible shield is more important than Earth's magnetic field, generated by the movement of molten metals within our planet's outer core. This magnetic field stretches tens of thousands of kilometers into space, forming the magnetosphere, a protective region that deflects much of the charged particle radiation carried by the solar wind. Without Earth's magnetic field, the solar wind would interact far more directly with our atmosphere over long periods of time. Although the atmosphere itself is also preserved by gravity and influenced by many other physical processes, the magnetic field plays an essential role in reducing the impact of high-energy particles and helping maintain an environment where life can flourish. Most of us rarely think about it, because the things that protect us best often work in silence, like the steady heartbeat that continues while we sleep, like the atmosphere quietly holding warmth around our planet, like Earth's magnetic field gently embracing the world for billions of years. Even the space surrounding Earth is not a perfect vacuum. It contains extremely sparse atoms, plasma, charged particles, tiny micrometeoroids, electromagnetic radiation, and countless radio signals that human civilization has been sending into the cosmos for more than a century. Perhaps what we call empty space is simply a place our senses have not yet learned to perceive. Nature is often far more subtle than our eyes can reveal. Carl Gustav Jung once wrote in The Archetypes and the Collective Unconscious, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Those words are not about astronomy. They are about the inner life. Jung reminds us that hidden layers of the psyche continue to influence our thoughts, emotions, and choices, even when we are unaware of them. Placed beside the image of Earth in space, that idea takes on a beautifully symbolic meaning. When we look at our planet, we notice its oceans, forests, mountains, and cities. Yet it is the invisible forces that make life possible. The magnetic field cannot be seen. The Van Allen belts cannot be seen. The plasma surrounding our world cannot be seen. Even the air we breathe is, for the most part, invisible. And yet every one of these unseen companions protects us every moment of every day. Perhaps the human soul is much the same. What gives a person true strength is not always what others can see. Sometimes it is quiet virtues, compassion, patience, hope, or the ability to forgive. They do not shine like the aurora, nor do they announce themselves with great noise. Yet they become the invisible magnetic fields that help us remain steady through the storms of life. And as night continues to gently settle over the sky, imagine Earth still turning quietly through the darkness, embraced by layers of protection invisible to the eye. Perhaps the deepest beauty of the universe is found not only in the wonders that dazzle us, but also in the unseen forces that quietly sustain them. For just like the human soul, what is invisible is sometimes the strongest foundation upon which life, love, and hope are able to grow in peace. Part 9. The Birth and Life of Stars. In the previous chapters, we witnessed the birth of the universe, explored extraordinary planets, and looked back upon Earth as a blue island floating in the endless ocean of space. Tonight, our journey brings us to the quiet architects who have shaped the history of the cosmos itself, the stars. Whenever we look up at the night sky, it is easy to think of stars as nothing more than distant points of light. But every star has its own life story. Stars are born, they grow, they age, and they come to an end in remarkably different ways. Some live for only a few million years. Others will continue shining for far longer than the current age of the universe itself. Much like human lives, no two stories are ever exactly the same. Every story begins with a cloud. Between the stars lie immense regions filled with hydrogen, helium, and countless microscopic grains of dust. Astronomers call these vast clouds nebulae. From afar, they appear as delicate ribbons of colorful mist. Yet within that quiet beauty, nature is patiently preparing for the birth of something new. Over time, gravity begins pulling certain regions of a nebula inward. Gas and dust gather ever more densely. Pressure rises, temperature climbs. The remarkable thing is that no one directs the process. No invisible hand arranges it. There is only gravity, patiently doing its work over millions of years. When the core reaches a temperature of about 10 million degrees, hydrogen nuclei begin fusing into helium. Nuclear fusion ignites. A star is born. Its first light awakens in the darkness of space. Perhaps this is one of the universe's most beautiful images. From a cold and silent cloud emerges a new source of light, one capable of warming planets and, perhaps, one day nurturing life somewhere among the stars. But not all stars are alike. To the naked eye, most stars appear white. In reality, a star's color reveals the temperature of its surface. Red stars are relatively cool. Yellow stars, like our own sun, have surface temperatures of about 5,500 degrees Celsius. White and blue stars are far hotter, with surface temperatures that can reach tens of thousands of degrees Celsius. In the universe, color is more than beauty. It is a language through which nature quietly tells us the true character of every star. Curiously, the lives of stars also defy human intuition. We often assume that the larger something is, the longer it will endure. The stars tell a different story. Massive blue stars contain many times more material than our Sun. Because of their enormous mass, the pressure within their cores becomes extraordinarily intense. Nuclear fusion proceeds at a tremendous rate, releasing astonishing amounts of energy. They shine with breathtaking brilliance. But they also consume their fuel at an astonishing pace. Many blue stars survive for only a few million years, a very short lifetime compared with the billions of years enjoyed by smaller stars. On the opposite side of the cosmic picture are the red dwarfs. They are small, faint, unassuming, yet they burn their fuel with extraordinary patience. Astronomical models suggest that many red dwarfs may survive for trillions of years, far longer than the universe's present age of approximately 13.8 billion years. In fact, the universe is still too young for even a single red dwarf to have completed its entire life cycle. Perhaps nature is quietly whispering something very simple. The brightest light is not always the one that lasts the longest. Sometimes it is quiet endurance that outlives time itself. Not every star shines with constant brightness. Some stars grow brighter and dimmer in regular cycles. These are known as variable stars. The reasons for these changes vary widely. Some stars repeatedly expand and contract, almost as though they are breathing. Others become periodically eclipsed by a companion star. By studying variable stars, especially Cepheid variables, astronomers discovered one of the most powerful methods for measuring the distances to faraway galaxies. What first appears to be instability becomes the very key that allows us to understand the scale of the universe. Stars are also rarely born alone. Most emerge together within the same enormous nebula. These families become star clusters. Some are young clusters still wrapped in the clouds of gas and dust from which they formed. Others are ancient globular clusters, more than 12 billion years old, almost as old as the Milky Way itself. When we look at a star cluster, we are not simply seeing many stars gathered together. We are witnessing an entire family, members sharing the same origin, growing beneath the same cosmic sky. Yet eventually, each star follows its own unique path. Carl Gustav Jung, once wrote in iron, researches into the phenomenology of the self. The self is not only the center but also the whole circumference, which embraces both conscious and unconscious. It is the center of this totality, just as the ego is the center of consciousness. Jung was speaking about the self, the symbol of wholeness in analytical psychology. He was not writing about stars. Yet when we look into the heavens, it is difficult not to sense a beautiful parallel. Every star is born from the same fundamental elements. Yet no two stars are exactly alike. Some live brief but dazzling lives. Some burn quietly for trillions of years. Some spend their existence within crowded stellar families. Some wander in solitude through the darkness. Some pulse with ever-changing brightness. Others maintain a steady rhythm for billions of years. And every one of them fulfills its own role within the universe's vast symphony. Perhaps the same is true for us. We often worry because our lives do not resemble those of others. Some people find success very early. Others blossom in middle age. Some devote themselves quietly to the world without ever standing beneath the spotlight. But nature has never treated difference as a mistake. On the contrary, it is diversity that gives the night sky its beauty. And as you gently close your eyes in the stillness of the night, imagine billions of stars continuing to shine above you. Some have only just been born within distant nebulae. Some are approaching the final chapters of journeys that have lasted billions of years. Yet every one of them is living according to the rhythm the universe has given it. Perhaps that is the gentlest message the night sky offers each of us. You do not need to shine in anyone else's way. You need only be patient enough to become fully yourself, to live according to the rhythm of your own soul. And in time, your light will find the sky where it truly belongs. Part 10. The remnants of stars. Throughout our journey, stars have appeared as symbols of light. They warm their planets, illuminate entire galaxies, and quietly forge the elements that make life possible. But like every living thing on Earth, stars do not exist forever. Even the brightest lights in the universe eventually reach their end. And yet, there is something remarkable about nature. An ending is rarely just an ending. More often, it is the beginning of another story. Tonight, we will step into the final chapter of a star's life. It is not a dark chapter. On the contrary, it may be the most beautiful chapter of all, for from the remnants of a dying star, the universe begins preparing the birth of entirely new worlds. When a star many times more massive than our Sun has nearly exhausted the fuel in its core, the outward pressure produced by nuclear fusion gradually weakens. No longer able to resist its own immense gravity, the core collapses with astonishing speed. In an incredibly brief moment, matter is compressed beyond almost anything we can imagine. Electrons and protons combine to form neutrons. A neutron star is born. Try to picture this. An object more massive than the Sun, yet only about 20 kilometers across. If it was somehow possible, which in reality it is not, to bring a single teaspoon of neutron star matter back to Earth, it would weigh billions of tons. The matter inside is so incredibly dense that the atoms we know no longer exist in anything resembling their familiar form. It is one of the most extreme places nature has ever created. But not every neutron star remains quiet. Some spin dozens, hundreds, or even more than 700 times every second. From their magnetic poles they emit beams of radio waves or other forms of electromagnetic radiation. Whenever those beams sweep across Earth, we detect remarkably regular pulses, almost like the steady ticking of a cosmic clock. Astronomers call these objects pulsars. Within the immense vastness of space, which often seems chaotic, there are rhythms of astonishing precision, as though the universe itself possesses a heartbeat. There is an even rarer kind of neutron star, the magnetar. If Earth's magnetic field is strong enough to guide the needle of a simple compass, a magnetar possesses the most powerful magnetic field ever known in nature. Its magnetic field is so intense that, were one to appear dangerously close to Earth, It could seriously affect electronics and matter across enormous distances. Fortunately, all known magnetars lie safely far away from our planet, even within what appears to be the cold remains of a dead star. Nature still hides extraordinary power. Yet before becoming neutron stars, many massive stars pass through one of the universe's most spectacular events, a supernova. As the star's core collapses, its outer layers are blasted violently into space. For a brief period, a single supernova can shine more brightly than an entire galaxy containing hundreds of billions of stars. This is not nature's fury. It is the moment the universe sows new seeds. Within these tremendous explosions, many elements heavier than iron are forged before being scattered across space. The carbon within our bodies, the oxygen we breathe, the calcium in our bones, the silicon beneath our feet, all carry the fingerprints of stars that died long before our world was born. But there is an even more astonishing story. For many years, scientists wondered where gold, platinum, and many of the heaviest elements in nature were created. Today, modern observations show that a significant portion of these elements is formed during the collision of two neutron stars. When these incredibly dense objects merge, the neutron-rich environment allows a process known as rapid neutron capture, or the R process, to occur. During this process, many heavy elements are created before being scattered throughout the cosmos. That means the gold ring someone wears today may contain atoms that were born in a neutron star merger billions of years ago. It is difficult to imagine a more beautiful story than that. Not only the light of the stars, but even the beauty humanity treasures, was born from the universe's most violent transformations. Not every star, however, ends in an explosion. Stars with masses similar to our Sun follow a gentler path. After expanding into red giants and shedding their outer layers, their remaining cores collapse into white dwarfs. No more nuclear fusion, no more newly generated energy. The star simply continues glowing with the heat it has already stored, slowly cooling over unimaginably long spans of time. A gentle light, no longer dazzling, yet still quietly telling the rest of its story. One of the stars that astronomers watch most closely today is Betelgeuse, the great red supergiant in the constellation Orion. Betelgeuse has entered the final stage of its life and will certainly explode as a supernova sometime in the astronomical future. But that future may arrive tens of thousands of years from now, or perhaps hundreds of thousands of years from now. Based on current scientific understanding, no one can yet predict exactly when the explosion will occur. And what of our own Sun? In about 5 billion years, the Sun will gradually exhaust the hydrogen in its core and expand into a red giant. Its outer layers will swell enormously before drifting away into space, while its core ultimately contracts into a white dwarf. The Sun is simply not massive enough to become either a neutron star or a black hole. Its ending will not come through a violent explosion, but through quietness, like a lamp that slowly grows dim. After illuminating an entire room for a very long time, Carl Gustav Jung once wrote in The Structure and Dynamics of the Psyche, "There is no coming to consciousness without pain." Jung was speaking about the growth of the human spirit. He meant that becoming more deeply aware of ourselves often requires passing through loss, crisis, and profound transformation. He was not writing about stars or supernovae, yet through the language of symbolism, it is difficult not to feel a deeply moving parallel. No star creates its most precious elements during the most peaceful period of its life. It offers those gifts only as it reaches its final chapters. Perhaps the same is true for us. Sometimes the experiences that seem the harshest become the very places where compassion, forgiveness, wisdom, and inner strength are born. Not because suffering is, in itself, something beautiful, but because human beings possess the remarkable ability to discover meaning, even among what appears to be only the remnants And as night continues to embrace the sky, look for a star quietly shining above you. Perhaps millions of years from now it will be gone. Perhaps the light reaching your eyes tonight is already the final chapter of a story that began unimaginably long ago. Yet from that ending, new elements will one day be forged. New planets will take shape, and somewhere in a distant corner of the universe, new life may awaken for the very first time. Perhaps in the universe, as in the human soul, an ending has never truly been the end. Sometimes, it is simply the quiet way nature begins a new beginning. Part 11. Black holes and space-time. Perhaps no object in the universe has stirred the human imagination more than the black hole. The name alone evokes visions of a bottomless abyss, a place where all light disappears and every mystery is swallowed forever. In novels, films, and popular imagination, black holes are often portrayed as enormous cosmic vacuum cleaners, consuming everything that ventures too close. But like so many of nature's greatest wonders, the truth is far more subtle. Tonight, let every thought gradually become still. Together, we will step into one of the most mysterious realms science has ever explored, not to seek fear, but to appreciate the extraordinary beauty of space-time, gravity, and the profound laws that quietly hold the universe together. At the center of the Milky Way, about 26,000 light-years from Earth, lies a supermassive black hole, known as Sagittarius A. Although the black hole itself emits no light, astronomers know it is there by watching the stars racing around an invisible point at astonishing speeds. It is like watching leaves whirl in the wind. You cannot see the wind itself, yet you know it is there. Black holes are much the same. We do not see the black hole itself. We see the traces it leaves upon the universe. One of the most common misconceptions is that a black hole behaves like a gigantic vacuum cleaner, pulling everything in the universe toward it. That is not how it works. If the sun could somehow be instantly replaced by a black hole of exactly the same mass, a purely hypothetical thought experiment, Earth would continue orbiting in almost exactly the same path. At that distance, gravity would remain unchanged, simply because the sun's mass had been compressed into a black hole. What makes a black hole extraordinary is not that it pulls more strongly from far away. It is what happens when you come close enough. Near the black hole, space-time becomes so intensely curved that once light crosses the event horizon, it can no longer escape. We usually imagine light traveling in straight lines. Across most of the universe, that is an excellent approximation. But near a black hole, light must follow curved paths created by the distortion of space-time itself. There even exists a region called the photon sphere, where, in theory, light can orbit the black hole in nearly circular paths. Yet these orbits are extraordinarily unstable. The slightest disturbance causes a photon either to plunge inward or escape forever. How remarkable! Even light, the very thing we often regard as the symbol of freedom, must obey the laws of the universe. Sagittarius. Afar is not unique. Today, astronomers believe that most large galaxies harbor a supermassive black hole at their centers. Some contain masses millions or even billions of times greater than our Sun. These black holes do not wander through space hunting stars. Instead, they quietly evolve alongside their galaxies for billions of years, shaping their surroundings through their immense gravitational influence. A completely dark object, helping define the structure of an entire galaxy. In 1974, the physicist Stephen Hawking proposed an idea that forever changed our understanding of black holes. By combining quantum mechanics with black hole physics, he showed that black holes may not be completely black after all. According to theory, they can emit an incredibly faint form of radiation now known as Hawking radiation. For black holes with astronomical masses, this radiation is far too weak to be detected directly using today's technology. Even so, Hawking's idea opened an entirely new path toward unifying the two great pillars of modern physics, general relativity and quantum mechanics. Sometimes, one small question is enough to transform humanity's understanding of the universe. Then, in 2015, humanity directly detected gravitational waves for the very first time, phenomena that Albert Einstein had predicted a century earlier. When two black holes orbit each other and eventually merge, they create ripples in the very fabric of space-time. Those ripples travel across the universe at the speed of light, carrying information about the cataclysmic event that produced them. It is difficult to imagine. Space is not merely the place where everything exists. Space itself can vibrate. That realization brings us back to one of the most elegant ideas in general relativity. Gravity is not an invisible rope pulling objects toward one another. Instead, matter and energy bend space-time itself. Planets, stars, and galaxies simply follow the natural paths within that curved geometry. Like a marble rolling across a stretched sheet that has sagged beneath a heavy weight. The marble is not being pulled by an invisible hand. It is simply following the shape of the surface beneath it. Even gravity does not act instantaneously. If the sun were to disappear, a purely hypothetical example used only to illustrate the physics, both the last sunlight and the change in the sun's gravitational influence would take about 8 minutes and 20 seconds to pulsar, reach Earth. Because both propagate at the speed of light according to general relativity, the universe contains no truly instantaneous signals. Every piece of information takes time to travel. Remarkably, these ideas, which once seemed so abstract, quietly shape our everyday lives. The GPS navigation system works accurately only because the atomic clocks aboard its satellites are continuously corrected for the effects predicted by both special relativity and general relativity. Without those corrections, positioning errors would accumulate rapidly, growing to many kilometers in only a short time. Some theories begin as equations written upon paper and quietly become part of everyday life. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "The decisive question for man is he related to something infinite or not?" Jung was speaking about humanity's search for meaning and our relationship with something greater than the individual self. He was not writing about black holes, gravitational waves, or relativity. Yet beneath the night sky, his question seems to resonate with extraordinary depth. Black holes often make us think of darkness, but perhaps the greatest wonder is that, by studying darkness itself, humanity has come to understand more about light, space-time, and the deepest laws of nature. Perhaps the human soul possesses a similar beauty. Each of us carries unexplored regions, unnamed memories, and quiet places that seem dark at first. They are not necessarily places to fear. Sometimes, it is only by patiently looking into those shadows that we discover what truly illuminates our lives. And as night continues to gently embrace the sky, imagine Sagittarius A times still resting quietly at the heart of the Milky Way, just as it has for billions of years. It gives off no light, yet it helps shape an entire galaxy. Perhaps our own lives are much the same. Not everything that matters is brilliant or easily seen. Sometimes it is the deepest silences, the unanswered questions, and the invisible forces within us that quietly bend the trajectory of an entire lifetime. Part 12. The earliest history of the universe. If every star has a childhood, every galaxy has a beginning, and every planet carries within it a story that unfolds over billions of years, then tonight our journey will take us farther back than ever before. We will return to a time before any star had begun to shine, before any planet circled a Sunday, before there was a sky, before there were eyes to gaze upon the universe. This was the earliest age of everything, a time when space, time, and matter themselves were still coming into being. For many years, people imagined the Big Bang as a colossal explosion erupting into empty space. According to modern cosmology, however, that picture is not quite accurate. The Big Bang was not a bomb exploding into a pre-existing universe. It was the earliest stage during which space itself began expanding, carrying matter and energy outward in every direction. There was no central point from which the explosion spread. There is no location in today's universe that can be called the place where every galaxy began moving away from. Space itself is what has been expanding. Perhaps this is one of the most beautiful ideas science has ever given us. The universe did not grow by expanding into a larger box. The box itself has been growing together with everything inside it. During the first moments after the Big Bang, temperatures were so unimaginably high that the atoms familiar to us today could not yet exist. The universe was an intensely hot ocean of fundamental particles and radiation constantly colliding with one another. Photons, the particles of light, could not travel freely because they were continually scattered by free electrons. Light already existed, but it could not yet journey through space. The universe resembled an impossibly dense fog, not because there was no light, but because light had not yet found its path. Time continued to flow. About 380,000 years after the Big Bang, the temperature had fallen to roughly 3,000 Kelvin. At that point, electrons began combining with protons to form the first neutral hydrogen atoms, while neutral helium also emerged during this era. Because photons were no longer scattered constantly by free electrons, they were finally able to travel almost freely throughout the cosmos. Cosmologists call this period recombination. From that moment onward, the universe became transparent. It was not the instant when someone switched on a lamp. It was the moment when the curtain covering the light was gently drawn aside. For the first time, light could begin its journey across billions of years. The remarkable truth is that some of those very photons still exist today. They have traveled for more than 13.8 billion years, passing through the birth of countless galaxies, witnessing the first stars ignite, watching supernovae explode and planets take shape, before finally reaching modern telescopes here on Earth. We call this ancient light the cosmic microwave background, or CMB. It is not the light of a star, nor the light of a galaxy. It is the lingering afterglow of the universe's own childhood. When it was first released, this radiation had a temperature of about 3,000 Kelvin. But because space itself has continued expanding for billions of years, its wavelength has been stretched dramatically. Today, it corresponds to a temperature of only about 2.7 Kelvin, placing it within the microwave region of the electromagnetic spectrum. Whenever scientists observe the cosmic microwave background, they are doing far more than measuring a physical signal. They are looking at the oldest picture humanity has ever seen, a photograph taken when the universe itself was only about 380,000 years old. How extraordinary! Humanity has never invented a camera capable of traveling backward through time, yet light itself has done exactly that for us. The first atoms formed during this era consisted almost entirely of hydrogen and helium. They were astonishingly simple, yet from that simplicity, gravity gradually gathered them into enormous clouds of gas. Over hundreds of millions of years, the first stars were born. Within those stars, heavier elements were forged. Generation after generation of stellar birth and death created carbon, oxygen, iron, and countless other elements. And eventually, from those first simple atoms, came forests, oceans, life, and even human beings quietly listening to this story on a peaceful night. What moves astronomers most deeply is not merely that the cosmic microwave background exists. It is that this ancient light is almost perfectly uniform in every direction across the sky. Only the tiniest fluctuations remain. Temperature differences of merely a few millionths of a degree. Those almost imperceptible ripples became the original seeds from which gravity slowly built galaxies, galaxy clusters, and the immense cosmic web we observe today. Sometimes, The smallest differences become the beginnings of the greatest things. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "In each of us there is another whom we do not know." Jung was speaking about the hidden depths of the inner life, the undiscovered parts of ourselves still waiting to be revealed. He was not writing about the Big Bang or the cosmic microwave background. Yet through the language of symbolism, it is difficult not to sense a quiet resonance. There was once a time when light already existed, yet could not be seen, not because it was absent, but because the conditions that would allow it to shine had not yet arrived. Perhaps the human soul is much the same. Within each of us lie abilities, qualities, and seeds of growth that quietly exist long before they become visible. Sometimes they cannot emerge immediately, not because they are unreal, but because life itself still needs time for the right conditions to take shape. Just as the universe required hundreds of thousands of years before light could travel freely, we too sometimes need many years of experience before the deepest parts of ourselves are finally able to speak. And as night continues to gently embrace the world, imagine that somewhere among the stars, photons that began their journey at the dawn of the universe are still traveling through space, carrying the story of the beginning. They bring no sound. They carry no words. They carry only the memory of light. Perhaps, like the deepest memories within every human soul, the oldest things never truly disappear. In Nazca, they simply wait for a moment quiet enough for us to recognize that, from the very beginning, light has always been part of the magnificent story we call the universe. Part 13. The Evolution of Galaxies. After traveling together to the very first moments of the universe when light was only beginning to find its way through the blazing fog of cosmic infancy, tonight our journey continues on an even grander scale. No longer is this the story of a single star or a single planet. It is the story of the great cities of the cosmos, the galaxies. If every star is a candle, then a galaxy is an entire sky filled with light. The Milky Way, home to our Sun and Earth, contains several 100 billion stars, along with countless planets, nebulae, star clusters, and vast clouds of gas and dust stretching across more than 100,000 light-years. Yet even the Milky Way is only an ordinary member among the hundreds of billions of galaxies that populate the observable universe. The remarkable truth is that galaxies did not appear fully formed. They, too, had a childhood. They grew, they evolved, and they continue to change with time. Modern observations show that most galaxies grow through a remarkably slow process known as galactic merger. Under the influence of gravity, smaller galaxies gradually drift toward one another. Over hundreds of millions or even billions of years, they begin to interact. Their spiral arms stretch and twist. Their clouds of gas become disturbed. And eventually, they merge into a single, larger galaxy. What is truly surprising is that during these colossal collisions, individual stars almost never crash into one another. The distances separating them are simply too vast. What truly collides are the immense clouds of gas, the gravitational fields, and the overall structures of the galaxies themselves. A merger of unimaginable proportions, taking place in profound silence. Our own Milky Way is following that very path. About 2.5 million light-years away lies the Andromeda Galaxy, the nearest large spiral galaxy to our own. Precise measurements show that Andromeda is moving toward the Milky Way at a speed of more than 100 kilometers per second. In about 4 to 5 billion years, the two galaxies will begin to merge. It sounds like a cosmic catastrophe, yet reality is far gentler. Because the stars are separated by such immense distances, the chance that our Sun will collide directly with another star is extraordinarily small. Instead, the night sky of the distant future will slowly transform. Rivers of stars will stretch, curve, and gradually blend together in a celestial dance lasting billions of years. If anyone is still standing on a planet to witness that sky, They may behold one of the most magnificent sights any civilization could ever see. Yet there is another thought that fascinates astronomers. With each passing year, studying the distant universe will gradually become more difficult. The reason lies in the expansion of space itself. In 1929, Edwin Hubble discovered that most galaxies are moving away from us. As space expands, the wavelengths of their light are stretched, shifting their colors toward the red end of the spectrum. This phenomenon is known as cosmological redshift. It is not because galaxies are racing through a motionless universe. It is because the space between them is continually growing larger. Imagine tiny dots drawn upon the surface of a balloon. As the balloon inflates, every dot sees every other dot moving farther away. No dot is the center. Only the surface itself is expanding. Even more surprising, astronomers discovered near the end of the 20th century that the universe's expansion is not slowing down, as many had once expected. Instead, it is accelerating. To explain this astonishing observation, scientists use the concept of dark energy, a mysterious component that appears to account for about 68% of the universe's total energy density. To this day, the true nature of dark energy remains unknown. We recognize its presence only through the way it influences the expansion of space. One of the strangest truths in modern science is that the thing comprising most of the universe is something we still do not understand. Nor is dark energy our only great mystery. Dark matter remains equally enigmatic. The stars within galaxies orbit far faster than can be explained by the visible matter alone. Observations of gravitational lensing and the formation of large-scale cosmic structures likewise suggest that there must exist a form of matter that neither emits, absorbs, nor reflects light, yet still exerts gravity. Scientists call it dark matter. According to current cosmological models, dark matter makes up about 27% of the universe's total energy density. That means every star, every planet, every human being, and every galaxy we can see together account for only a very small fraction of the complete cosmic picture. Perhaps the most astonishing truth is not that the universe is unimaginably vast. It is that we still know so little about it. On even larger scales, galaxies are not scattered randomly through space. They gather into clusters, superclusters, and enormous filaments stretching across hundreds of millions of light years, forming an immense structure known as the cosmic web. Between these filaments lie enormous cosmic voids where very few galaxies exist. Seen from far enough away, the universe resembles an intricate web, or even the branching network of neurons inside a brain. These two structures are not physically alike, nor did they arise in the same way. Yet the visual resemblance has left many people marveling at the beauty nature creates across completely different scales. Carl Gustav Jung once wrote in The Archetypes and the Collective Unconscious, "The individual is not only a single, separate being, but, by his very existence, presupposes a collective relationship." Jung was speaking about the social and psychological nature of human existence. He believed that every individual exists within relationships extending far beyond the self. He was not writing about galaxies or the cosmic web. Yet, through the language of symbolism, it is difficult not to sense a meaningful resonance. No galaxy is truly alone. Every galaxy is influenced by the gravity of others. Every movement contributes to the architecture of the universe itself. Perhaps the same is true for us. We often imagine ourselves as separate individuals, yet every life is woven from countless connections: family, friends, memories, love, chance encounters, and even the people who pass through our lives only briefly. Just as galaxies grow through encounters and mergers spanning billions of years, the human soul is also enlarged through quiet connections that we may not even notice as they happen. And as night continues to gently settle across the sky, imagine Andromeda still making its silent journey toward the Milky Way, keeping an appointment billions of years in the making. Across the cosmic web, galaxies continue their endless motion, while space itself quietly expands. Perhaps the deepest beauty of the universe lies not in permanence, but in movement, in connection, in countless parts coming together to write a story greater than any single one could ever tell alone. And perhaps it is within that vast network of connections that we discover our own small, yet deeply meaningful place among the stars. Part 14. The immense structure of the universe. Tonight, our journey will carry us farther than on any night before. No longer will we focus on a single star, a single planet, or even a single galaxy. Instead, we will step back and behold the vast tapestry the universe has been quietly weaving for nearly 14 billion years. If Earth is a grain of sand, if the Milky Way is an island, then the universe is an endless ocean, where hundreds of billions of islands of light drift silently through an immeasurable sea of space. Every galaxy has its own unique form. Some are spiral galaxies, their graceful arms curving around brilliant central cores, much like our own Milky Way. Others are elliptical galaxies, round or oval in shape, where gas and dust have become too scarce to give birth to many new stars. Still others possess no clear form at all, their structures reshaped by ancient interactions and collisions. Nature never seems to repeat itself. It creates with the same laws, yet gives rise to endlessly different forms. Among them, elliptical galaxies possess a beauty all their own. Their dramatic spiral arms have long since disappeared. Their brilliant star-forming regions have faded. Their light comes chiefly from ancient stars that have endured for billions of years. They move within structures that are quieter and more stable, as though, after all the turbulence of youth, an entire galaxy has entered a season of calm maturity. Perhaps even galaxies have their youth and their adulthood, yet not every galaxy lives in quiet stillness. Billions of light years away, astronomers observe objects so extraordinarily luminous that they outshine the entire galaxies that contain them. These are quasars. For decades, quasars were among astronomy's greatest mysteries. Today we understand that most quasars are young galaxies whose supermassive black holes are consuming matter at astonishing rates. As gas and dust spiral into the accretion disk surrounding the black hole, friction heats the material to extraordinary temperatures, releasing tremendous amounts of energy. The fascinating truth is this: it is not the black hole itself that shines. It is the matter on its way toward it. In many quasars and other active galaxies, enormous streams of matter are also launched outward from the regions surrounding the black hole, known as relativistic jets. These streams consist of charged particles traveling at speeds close to that of light, extending thousands or even millions of light-years beyond their host galaxies. A completely dark object can help create some of the brightest structures in the universe. It is one of nature's most beautiful paradoxes. As modern telescopes peer ever farther into space, they also look ever deeper into the past. Because light requires time to cross the immense distances of the cosmos, observing a galaxy 10 billion light-years away means seeing it as it existed 10 billion years ago. Through these observations, astronomers have discovered some of the earliest galaxies, appearing only a few 100 million years after the Big Bang. They were smaller, richer in gas, and experiencing extraordinary bursts of star formation. They are like the opening chapters of the great book called the universe. Galaxies also do not live in isolation. Under the influence of gravity, they gather into galaxy clusters, and those clusters, in turn, become part of enormous superclusters. A single cluster may contain hundreds or even thousands of galaxies, along with vast reservoirs of hot gas and enormous quantities of dark matter holding the entire system together. Viewed on that scale, an individual galaxy is little more than a single house within an immense city. Yet between these cosmic cities lie regions that are almost empty, Cosmologists call them cosmic voids. These enormous regions span tens to hundreds of millions of light-years, containing remarkably few galaxies. They are not completely empty, but their matter density is dramatically lower than that of the surrounding universe. It is precisely the contrast between dense galaxy clusters and immense cosmic voids that gives the large-scale universe its extraordinary beauty. Just as in music, silence is every bit as important as sound. To this day, humanity has observed only a portion of the entire universe. That region is known as the observable universe, extending to a radius of about 46.5 billion light-years from Earth in every direction. This limit does not exist because the universe ends there. Rather, light from more distant regions has simply not had enough time to reach us since the Big Bang, which also means, beyond our cosmic horizon, there may be countless wonders we have never seen. According to today's cosmological models, space itself may extend far beyond the portion we can observe. Current evidence does not allow us to determine whether the entire universe is finite or infinite. Both possibilities remain under consideration within different physical models. Perhaps the most beautiful thing about science is its willingness to say, with complete honesty, we still do not know, because space expands in nearly the same way in every direction. The standard model of cosmology contains no center of the universe. There is no privileged point from which all galaxies are moving away. An observer in any galaxy would see distant galaxies, on average, receding because space itself is expanding. That realization completely changes how we see our own place in existence. We do not live at the center, nor do we live at the edge. We are simply one part of something vastly greater. Carl Gustav Jung once wrote in Aeon, researches into the phenomenology of the self. The self is not only the center, but also the whole circumference which embraces both conscious and unconscious. Jung was speaking about the self, the symbol of psychological wholeness in analytical psychology. He was not writing about the structure of the universe or the architecture of galaxies. Yet through the language of symbolism, his words invite a quiet reflection. Human beings spend much of life searching for a center, a place of absolute safety, a final answer, or a foundation that never changes. But the universe seems to tell a different story. It exists in remarkable harmony without requiring a physical center. Order arises not from a privileged position, but from the relationships among countless parts existing together. Perhaps the human soul is much the same. Maturity does not come from placing the ego at the center of everything. It comes when we become open enough to recognize that we are always part of something larger. Our families, humanity, nature, and the universe itself. Just as galaxies unite to form immense clusters, every encounter, every memory, and every experience quietly helps shape the person we are becoming. And as night continues to spread gently across the sky, imagine hundreds of billions of galaxies still moving through a universe that never ceases to expand. Between brilliant clusters and vast cosmic voids, there is no single center and no final edge. There is only an immense symphony of space and time, still unfolding. Perhaps, like the human soul itself, the deepest beauty is not found in discovering the center of everything, but in realizing that we have always belonged to a greater whole, more mysterious, more beautiful, and far more meaningful than our eyes alone could ever perceive. Part 15. Worlds beyond the solar system. After journeying together through immense galaxies, vast cosmic voids, and the invisible web connecting hundreds of billions of islands of light, tonight, we embark on a voyage that feels a little closer to the human imagination. We are leaving the solar system, the home that has nurtured life for more than 4 billion years, to visit worlds that quietly circle distant stars. Perhaps, ever since humanity first looked up at the night sky, One question has accompanied us through every generation. Could there be another world like Earth? Today, science offers an answer that is both humble and extraordinary. Yes, astronomers call them exoplanets, planets that orbit stars beyond our solar system. Since the first exoplanet orbiting a sun-like star was confirmed in 1995, humanity has discovered thousands of new worlds, and that number continues to grow as increasingly powerful telescopes explore the cosmos. What is truly remarkable is this: our solar system may not be the only kind of planetary system nature creates. Among these distant worlds are planets that orbit two suns at the same time. If you could stand upon the surface of such a planet, assuming it possessed solid ground and suitable conditions, you might witness two sunrises, two sunsets, or both stars shining together above the horizon. A sight that generations of people once believed belonged only to science fiction, yet nature created such worlds long before we imagined them. Not every planet resembles Earth. Some are enormous gas giants known as hot Jupiters. They possess masses comparable to or even greater than that of Jupiter, yet orbit astonishingly close to their parent stars, completing an entire year in only a matter of days. Their extreme proximity raises atmospheric temperatures to thousands of degrees, heating their clouds until their skies become places of extraordinary violence. Nothing like them exists within our own solar system. Nature always finds ways to exceed our imagination. Some exoplanets become so intensely heated that their surface or atmospheric temperatures exceed those of the smallest red dwarf stars. This does not mean the planets generate light through nuclear fusion, as stars do. Rather, they receive such overwhelming amounts of radiation from their nearby host stars that their surfaces and atmospheres are heated to astonishing temperatures. There are places where both day and night burn with relentless fire, where no oceans like ours could ever exist. On planets such as HD 189733b, atmospheric models and spectroscopic observations suggest that glass rain may occur. Tiny silicate particles condense high in the atmosphere before being swept sideways by winds reaching thousands of kilometers per hour. A rainstorm, not of water, but of razor-sharp shards of glass. Elsewhere, scientists have identified remarkably dense planets, such as 55 Cancri E. Years ago, researchers proposed that its carbon-rich composition might allow enormous quantities of diamond to form within its interior. Today, newer models suggest that the planet's composition is likely far more complex, meaning the idea of an entire diamond planet remains an intriguing hypothesis rather than an established fact. Perhaps the most important point is not whether the entire planet truly consists of diamond. It is that nature continually reminds us the universe is capable of possibilities far beyond anything humanity has imagined. Not every world is dry and barren. Some theoretical models predict the existence of ocean worlds, where water may cover nearly the entire surface or extend hundreds of kilometers deep before transforming into high-pressure forms of ice far below. Imagine such a place. A planet with almost no continents, only one endless ocean, reflecting the light of a distant and unfamiliar sun. Among these remarkable worlds is a special category known as super-Earths. The name refers only to their size or mass larger than Earth, yet smaller than Neptune. It does not imply that they resemble Earth in habitability. Some may be rocky worlds. Some may contain enormous amounts of water. Others may possess dense atmospheres and extraordinarily hostile temperatures. Perhaps even worlds that share the same name still carry entirely different stories. Then there are the rogue planets. They orbit no star at all. Many may have been ejected from their original planetary systems through gravitational interactions with other planets or neighboring stars early in their histories. Since then, they have wandered silently through the darkness between the stars. No sunrise, no sunset. A journey without a destination, without a sun to call home. Yet the greatest question humanity continues to ask remains unchanged. Could life exist somewhere beyond Earth? One of the most promising places scientists investigate today is the family of planets orbiting red dwarf stars. Red dwarfs are the most common type of star in the Milky Way. Because they are smaller and cooler than our Sun, the region where liquid water might exist, the habitable zone, lies much closer to the star. That creates both hope and formidable challenges. Such planets may endure powerful stellar radiation, intense stellar winds, or become tidally locked, with one hemisphere forever facing its star, while the other remains in perpetual darkness. To this day, we still do not know whether somewhere out there another living world truly exists. Carl Gustav Jung once wrote in Modern Man in Search of a Soul, "The least of things with a meaning is worth more in life than the greatest of things without it." Jung was speaking about meaning in human life. He was not writing about exoplanets or the possibility of life beyond Earth. Yet, through the language of symbolism, his words invite a gentle reflection. Human beings have always been drawn toward what lies far away. Strange planets, other suns, galaxies we have never reached. But perhaps what we seek is not merely another place to explore. Perhaps we are searching for the answer to an even deeper question. Whether life, whether consciousness, whether the longing to love and to understand belongs only to Earth. Perhaps that search reveals something profoundly human. We continue lifting our eyes toward the heavens because, somewhere deep within us, we long to know that we are not alone in the universe. Yet even if science someday discovers unmistakable signs of life on a distant world, the greatest treasure will remain unchanged. Our ability to feel wonder, to ask questions, and to cherish the extraordinary gift of life already present here on our own blue planet. And as night continues to gently settle across the sky, imagine that beyond our solar system, billions of worlds are still quietly circling unfamiliar stars. Some greet the dawn beneath two suns. Some endure storms of falling glass. Some are covered by endless oceans. Some wander alone through eternal darkness without ever knowing a sunrise. Every planet tells a different story, just as every human life is uniquely its own. And perhaps the greatest beauty of the universe is not that we have found every answer, but that there are still countless mysteries inviting the human heart to keep looking upward, with curiosity, with humility, and with hope. Part 16. The machines that help humanity see farther. After journeying together across immense galaxies, mysterious black holes, and distant worlds orbiting other stars, you may naturally find yourself asking a simple question. How do we know all of this? How can humanity speak about galaxies billions of light years away, the atmospheres of planets we have never visited, or tiny objects quietly drifting along the outer edges of the solar system? The answer lies not only in human intelligence, it also lies in our machines. Machines built not to conquer the universe, but to learn how to listen to it. Perhaps never before in history has humanity possessed a pair of eyes as powerful as the James Webb Space Telescope. Orbiting the Sun near the Lagrange L2 point, about 1.5 million kilometers from Earth, James Webb observes the universe primarily in infrared light. This allows it to see through the dense clouds of dust where stars are born, and to detect light from some of the earliest galaxies, light whose wavelengths have been stretched by the expansion of the universe. The first images James Webb returned left millions of people around the world speechless, not because they were simply beautiful, but because they revealed that the universe is far deeper than we had ever imagined. Yet James Webb does much more than take pictures. One of its most extraordinary abilities is analyzing the atmospheres of exoplanets. When a planet passes in front of its host star, an incredibly small portion of the starlight filters through the planet's atmosphere before reaching the telescope. By studying which wavelengths are absorbed, scientists can detect the presence of molecules such as water vapor, carbon dioxide, methane, and many others. It is astonishing. We have never touched those distant worlds, yet we have already learned to read the signatures, written into their atmospheres, like recognizing someone's presence, simply by the sound of their breathing. Many years before James Webb, another image forever changed humanity's view of its place in the universe. In 1995, the Hubble Space Telescope was pointed toward a tiny region of sky that appeared almost completely empty. For many consecutive days, Hubble patiently gathered every faint photon it could find. The result became known as the Hubble Deep Field. Within that tiny patch of darkness, thousands of galaxies suddenly appeared, each containing billions of stars. What had once seemed to be empty space became an ocean of light. Sometimes, we fail to see something, not because it is absent, but because we have not yet looked with enough patience. Not every secret of the universe shines in visible light. Many celestial objects emit only radio waves. That is why humanity has built enormous radio telescopes, their giant parabolic dishes stretching across quiet deserts and high plateaus. They listen for faint signals from clouds of hydrogen, pulsars, active galaxies, and countless other phenomena invisible to the human eye. If optical telescopes are like our eyes, then radio telescopes are like our ears. The universe does not speak only through light, it has echoes as well. Some machines do not remain still to observe. They deliberately venture into the most dangerous places imaginable. The Parker Solar Probe is one of them. This remarkable spacecraft repeatedly flies closer to the Sun than any spacecraft before it, passing directly through the Sun's outer atmosphere, the corona, to study its magnetic fields, the solar wind, and the origins of high-energy particles. Although the surrounding environment reaches temperatures of millions of degrees, the spacecraft's scientific instruments continue operating safely behind an extraordinary heat shield. Humanity has not approached the Sunday to challenge nature. We have drawn nearer to understand it. While Parker races toward the light, another spacecraft quietly journeys into the darkness between the stars. That spacecraft is Voyager 1. Launched in 1977, Voyager 1 has traveled farther than any human-made object in history. Today, it has crossed beyond the heliosphere and continues its journey through interstellar space. Its radio signals now require more than a full day to reach Earth. Inside that small spacecraft rests the Golden Record, a collection of sounds, images, music, and greetings in many of humanity's languages. Perhaps it is a message in a bottle, cast into the greatest ocean humanity has ever known. On the opposite frontier of the solar system, New Horizons gave us our first close-up views of Pluto in 2015. A world that had once appeared as nothing more than a tiny point of light suddenly revealed vast plains of nitrogen ice, towering mountains of water ice, and landscapes filled with astonishing geological complexity. A world we thought we already knew became entirely new. Humanity has not only learned to observe from afar, we have also begun bringing tiny pieces of the universe home. Missions such as Hayabusa 2 and OSIRIS-REx successfully collected samples from asteroids and returned them to laboratories on Earth. Within those tiny grains of dust may lie materials preserved almost unchanged since the birth of the solar system, helping scientists understand how planets formed and how the earliest organic compounds first appeared. Sometimes, a single grain of dust can tell a story, spanning billions of years. Carl Gustav Jung once wrote in Modern Man in Search of a Soul, "Knowledge rests not upon truth alone, but upon error also." Jung was speaking about the growth of human understanding. He believed that knowledge is built not only upon what is correct, but also upon mistakes, experiments, and the limitations we gradually learn to overcome. He was not writing about telescopes or space probes, yet through the language of symbolism, it is difficult not to recognize a meaningful parallel. Every machine humanity sends into space is an extension of our eyes, our ears, and our curiosity. They do not replace us. They simply help us see farther, listen more carefully, and become more humble before all that we still do not know. Perhaps the journey inward is much the same. No one can see the whole of themselves in a single moment. We need time, we need observation, we need experience, and sometimes even failure, to understand who we truly are. Just as James Webb must patiently gather the faintest rays of light from the earliest age of the universe, the human soul also needs stillness to recognize the truths that have always been present, yet were too delicate to notice at first. And as night continues to gently embrace the sky, imagine that somewhere beyond the endless darkness, Voyager 1 is still quietly carrying Earth's greeting into the cosmos. Parker Solar Probe continues its daring journey around the Sunday. James Webb keeps collecting photons that began their voyage billions of years ago, and ancient grains of dust from distant asteroids continue telling the story of the solar system's dawn. Perhaps these remarkable machines do more than help us see farther into the universe. Perhaps they remind us that humanity's greatest achievement is not building extraordinary instruments, but never ceasing to ask questions, never ceasing to learn, and never losing our sense of wonder before the infinite beauty of the night sky. Part 17. The Search for Life Beyond Earth. Long before humanity built the first telescopes, long before we understood that Earth is only a small planet orbiting the Sunday, one question had already begun, quietly growing within the hearts of countless generations. Could it be that we are alone in the universe? This is not merely a question of astronomy. It is also a deeply human question. For when we look up at a sky filled with stars on a peaceful night, we are not only seeing the light of distant worlds, we are also seeing our longing to connect, to understand, and to know that life, the most fragile gift we have ever encountered, may not have blossomed on only one planet. Today, science no longer searches for aliens in the way movies often imagine them. Scientists are searching for something far more modest. They are searching for signs of life. In astronomy, these signs are known as biosignatures. They are not direct evidence that living organisms exist. Rather, they are chemical or physical signals that may suggest biological processes are taking place on a distant world. It is an approach built upon great caution, because science does not begin with certainty. Science begins with questions. How can we possibly know what is happening on a planet located tens, hundreds, or even thousands of light years from Earth? The answer, once again, is light. When an exoplanet passes in front of its host star, a tiny fraction of the starlight travels through the planet's atmosphere before reaching telescopes such as the James Webb Space Telescope. During that journey, molecules within the atmosphere absorb very specific wavelengths of light. Using spectroscopy, astronomers can identify the atmosphere's chemical composition without ever setting foot on that distant world. It is like listening to a symphony, simply to recognize which instruments are playing. Among the many molecules scientists study, oxygen, methane, and water vapor receive particular attention when discussing the possibility of life here on Earth. Most of the oxygen in our atmosphere is produced through photosynthesis carried out by living organisms. Methane can likewise be generated by many microorganisms, although it can also arise through geological processes unrelated to life. Water vapor, meanwhile, suggests the presence of water in gaseous form and offers clues about a planet's water cycle. Yet one fact remains critically important. None of these substances, by itself, is enough to prove that life exists. A planet with oxygen may have no living organisms. A planet with methane may also be lifeless. Even water, the precious condition we know so well, is not the final answer. What excites scientists most is the possibility of finding multiple biosignatures together. For example, if a planet possessed substantial amounts of both oxygen and methane in its atmosphere, that would be an especially intriguing discovery. These two gases naturally react with one another, meaning they generally require continuous replenishment to coexist over long periods. Even then, however, scientists would carefully investigate every possible natural explanation before considering the possibility of life. That is the beauty of science. It does not rush. It does not reach conclusions too quickly. It always leaves room for humility. To this day, humanity still possesses no confirmed evidence of life beyond Earth. Yet that does not make the search any less meaningful. Quite the opposite. Every new telescope, every more precise instrument, every newly discovered exoplanet brings that question just a little closer. The James Webb Space Telescope has already begun analyzing the atmospheres of numerous exoplanets with an unprecedented level of detail. In the future, a new generation of observatories, both on Earth and in space, will be capable of studying smaller, cooler planets with conditions more similar to our own world. Those advances may allow us to detect subtle biosignatures that remain beyond our reach today. Perhaps that day will come. Perhaps it still lies far ahead. But the journey has already begun. The most precious thing is not that science promises to answer every question. It is that science continually opens the door to new ones. Each time humanity believes it understands the universe a little better, the universe gently reveals another doorway. Like the horizon, the closer you walk toward it, the farther it expands. Perhaps the greatest wonder does not lie in what we already know. It lies in how much still remains to be discovered. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "The least of things with a meaning is worth more in life than the greatest of things without it." Jung was speaking about meaning in human life. He was not writing about exoplanets or biosignatures. Yet through the language of symbolism, his words offer a gentle perspective on humanity's search for life beyond Earth. What humanity seeks is not merely a molecule of oxygen, not merely a trace of methane, not merely a drop of water on a distant planet. Perhaps what we are truly searching for is meaning. The hope that life is not a solitary miracle scattered across an endless sea of stars. And perhaps, even if one day we discover compelling evidence of a biosignature on some distant world, that discovery will not make Earth any less extraordinary. Quite the opposite. It may teach us to cherish our own planet even more, because we will understand that life, wherever it appears, is the result of an unimaginably long, delicate, and precious journey. And as night continues to gently embrace the sky, imagine that somewhere far away, orbiting a faint and distant star, there may be a planet whose light has only just begun its long voyage toward us after passing through its atmosphere. Perhaps that light carries nothing unusual, or perhaps it carries a story humanity has never before heard. Whatever the final answer may be, the search itself reminds us that humanity's greatest beauty lies not only in our ability to explore the universe, but in our willingness to keep our hearts open to the unknown, with curiosity, with humility, and with a quiet hope that never fades. Part 18. Our place in the universe. And so, our journey tonight is slowly drawing to its final moments. Perhaps when this story began, you simply wanted to hear a few fascinating thoughts about the night sky before drifting off to sleep. But then, chapter by chapter, the universe quietly unfolded before us. Together, we traveled back to the very first moments of the cosmos, when space and time themselves emerged from the event science calls the Big Bang. We witnessed the oldest light in existence, still quietly journeying across nearly 14 billion years before reaching humanity's telescopes. We watched the first clouds of gas collapse into stars. Then generation after generation of stars were born, lived, shone, and ended their lives in magnificent supernova explosions, leaving behind the elements that would one day become planets, oceans, and even our own bodies. Together, we journeyed through the solar system, past frozen worlds, past moons that carry the promise of hidden oceans, past comets quietly returning after tens of thousands of years. Then we traveled beyond the Milky Way, to spiral galaxies, elliptical galaxies, brilliant quasars, supermassive black holes, and the immense cosmic web connecting hundreds of billions of galaxies like invisible threads woven into the great fabric of space. We visited worlds beyond the solar system, planets with 2 suns, storms of falling glass, endless oceans, wandering planets with no star to call home. And finally, we looked through the eyes of James Webb, Hubble, Voyager, and the Parker Solar Probe, allowing us to see farther, deeper, and listen more carefully to the story the universe has been quietly telling for billions of years. At last, we arrive at a question, perhaps the greatest question of all. Who are we amid all of this? If the nearly 14 billion-year history of the universe were compressed into a single calendar year, the entire history of human civilization would appear only during the final seconds before midnight on New Year's Eve. The lifetime of each one of us, measured on that same cosmic clock, would be little more than the blink of an eye. At first, that thought may make us feel very small, yet within it lies something profoundly beautiful, because no matter how small we may be, we are still part of that story. The carbon atoms within your body were forged inside stars that died long before Earth itself was born. The calcium in your bones, the iron in your blood, and the oxygen in every breath are gifts left behind by generations of ancient stars. In a very real sense, we are children of the stars. And while you are listening to these words, the universe has never stopped moving. Earth continues spinning upon its axis. At roughly 1,600 kilometers per hour at the equator, it continues its journey around the Sunday. The Sun continues orbiting the center of the Milky Way. The Milky Way continues moving toward Andromeda. Galaxies continue drifting through expanding space. New stars continue to be born. Others quietly come to the ends of their lives. Light continues its endless journey, whether anyone is there to see it or not. Everything is in motion, yet strangely, within a universe that never stands still, human beings have always searched for peace. Perhaps peace is not found when everything stops. Perhaps it comes when we stop resisting the natural flow of life. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "Who looks outside, dreams. Who looks inside, awakes." Throughout this journey, we have continually lifted our eyes toward the heavens, to distant galaxies, and the mysteries of space. But Jung reminds us that every outward journey can become an invitation to look inward. He was not writing about stars or cosmology, yet through the language of symbolism, the night sky seems to reflect something deeply human. The more we understand how small we are, the more humility we discover. The more we recognize ourselves as part of the universe, the more fully we learn to live within the present moment. Perhaps that is the greatest gift the night sky offers us. Not its enormous numbers, not its incomprehensible distances measured in billions of light years, but its quiet ability to teach us how to let go of the feeling that we must control everything, to let go of yesterday's worries, tomorrow's burdens, and all the things we cannot yet change. The night is still wonderfully quiet. Beyond your window, the stars continue shining softly. Though many of them began sending their light long before human history was ever written, the sky is never in a hurry. Neither is the universe. It simply continues moving according to its own timeless laws, just as it has for billions of years. And perhaps, tonight, you do not need to hurry either. Let your eyes close gently. Let your breathing become slower. Let every thought dissolve like thin clouds drifting across the night sky. If today has been a long day, you have done enough. If there are still things left unfinished, they will still be there when morning returns. For now, the only thing you need to do is allow yourself to rest, to be at peace, to drift into sleep beneath a sky filled with stars, where every ray of light quietly whispers that you are part of a story far greater than yourself. and that is precisely what makes your own existence so precious. Thank you for joining me on this journey, from the first moments of the Big Bang to the farthest reaches of the observable universe. If these stories have brought you even a little peace, a little wonder, and a gentler way of seeing both the universe and yourself, I invite you to subscribe to the channel and join me for future journeys. There are still countless mysteries of nature, science, and the human soul waiting for us to explore together. But for now, I wish you a peaceful night. May you sleep deeply, and may your dreams carry you once again among the stars, with a heart that is light, peaceful, and filled with hope. Good night.